In this video, we're going to talk about the AC method of factoring. So this is a method we're going to use if the leading coefficient of our trinomial is not 1. So our first step is going to be to put the trinomial in descending order. Our second step is something we've talked about quite a bit, which is to factor out a GCF. Our third step is going to be to multiply A and C. So remember that the form of these trinomials is ax squared plus bx plus c, where a is the coefficient of x squared and c is the constant, or the coefficient of the third term if we have two variables. So our third step is just to multiply those two together. After we've done that, we're going to find factors of a times c that we just did that add to equal b. Our fifth step is going to take the middle term, this bx term here, and break it apart into two terms using the two factors we found in step number 4. After step 5, where we've broken the middle term apart into two terms, we should now have 4 terms instead of 3, which means we can go ahead and factor by grouping. And then finally, after you've factored by grouping, you should be able to check your answer using multiplication or FOILing like we've talked about before. Okay, so here is our first example. We can see that this is a trinomial, 3 terms, with a leading coefficient greater than 1. So we're going to start by multiplying A and C together. So that's 5 times 2, which is 10. So now we're going to look for factors of 10 that add to equal 7. They're both going to be positive. So that's the same ones we just multiplied together, 2 and 5. So we're going to break this middle term apart into those two factors. So a positive 5x and a positive 2x. So we can see it still equals 7x. We're just writing it in a different way. We still have our 5x squared and our plus 2 from the original equation. Now we forced it to have 4 terms, which is going to allow us to use that factoring by grouping. Out of this first group here, we can factor out a 5x, so that will leave us with x plus 1. Out of the second group, we're going to factor out a positive 2, so remember that means we put plus 2 here. When we factor that out, that also leaves us with x plus 1. So you can see that our parentheses are the same, which is what needs to happen. So now that they both have that x plus 1, we can go ahead and factor it out, and that leaves us with this 5x and this plus 2 to make our second binomial. So this factors into x plus 1 times 5x plus 2. Remember, we could check this by FOILing and we would get exactly what we started with. Okay, in our second example, again, we have a leading coefficient greater than 1. There's no GCF to factor out, so we're going to start by multiplying 6 and negative 3 together, which is negative 18. So we're looking for factors of negative 18 that equal positive 7, which means our larger factor is positive. So those factors would be negative 2 and positive 9. We're going to break that middle term apart into a negative 2x and a plus 9x. And then we still have the 6x squared and the minus 3 from our trinomial. Now that we have 4 terms, we can go ahead and start grouping them. Out of the first group, we can factor out a 2x, which leaves us with 3x minus 1. Out of the second group, we can factor out a positive 3, so we'll put plus 3. That leaves us with 3x minus 1. Again, the parentheses are exactly the same, So we can factor out the 3x minus 1. And once we factor that out, it leaves us with this 2x and this plus 3, and that's what makes up our second binomial. So this factors into 3x minus 1 times 2x plus 3. For our third example, we're going to again start by checking for a GCF. We see that there isn't a GCF to factor out. So we're going to multiply 10 and negative 3 together, which gives us negative 30. Now we're going to look for factors of negative 30 that add to equal negative 13, which means the larger factor is negative. So that would be 2 and negative 15. If we multiply those, we get negative 30. If we add them, we get negative 13. So we're going to break this apart into a plus 2x and a minus 15x, again using those factors we just found. We still have the 10x squared, and we still have the minus 3. So now we can group the first two terms and the second two terms together. Out of our first group, we can factor out a 2x, which leaves us with 5x plus 1. Out of the second group, because we have this negative leading coefficient right here, instead of factoring out a positive 3, we're going to factor out a negative 3. So that will also leave us with 5x plus 1, because remember, we're dividing by a negative. Both sets of parentheses are the same, so we can factor out that 5x plus 1. And that will leave us with this 2x and this minus 3 to make up our second binomial. So this factors into 5x plus 1 times 2x minus 3. Now in this next one, what I want you to notice is that we have two variables. When this happens, we want to make sure that the squared terms are on the outside and the one that has the combined terms are in the middle. So we're going to actually treat this the same way that we've done all the others. We see that we have a leading coefficient greater than 1, so we're going to start by multiplying a and c together. So 3 times negative 8 is negative 24. So we want factors of negative 24 that we can add to get negative 10. So our larger factor is negative. So those factors would be 2 and negative 12. We're going to break this middle term apart into negative 12xy and then positive 2xy. So it still equals negative 10xy. We're just writing it with two terms instead of one. We have the 3x squared at the front and the minus 8y squared at the back. So then we're going to group the first two and the second two. Out of our first group, we can take out a 3x, which leaves us with x minus 4y. Out of our second group, we can factor out a positive 2y, which will also leave us with x minus 4y. Again, our parentheses are exactly the same, so we can factor out the x minus 4y. And that leaves us with this 3x and this plus 2y to create our second binomial. So this factors into x minus 4y times 3x plus 2y. Again, we're going to start by checking for a greatest common factor. There isn't one for this one, so we are going to multiply a times c, so 4 times 3 is 12. So we're going to look for factors of 12 that add to equal 20. So our options are 1 and 12, 2 and 6, or 3 and 4. Those are the only factors of 20. If you look, none of them add to equal 20. So we get sums of 13, 8, and 7. So once we've looked at every single possible factor of a times c, and we see that nothing works to make that middle factor, in this case 20, That is the only time that we can say that this is prime. There are no factors that'll work, so we cannot factor it. In this last example, the first thing you should notice is that we have a negative leading coefficient. So if nothing else, remember we have to factor the negative out first. But you should also notice that every single term is even, which means instead of factoring out just a negative, we can factor out a -2. So when we factor out that -2, that will leave us with y squared plus 2y minus 24. So this leaves us in these parentheses with a trinomial with a leading coefficient of 1, which means we don't need to use the AC method at all. All we have to do are find factors of -24 that add to equal +2. So if we look at our factors, where the larger one is positive, we have -1 and 24, -2 and 12, -3 and 8, or -4 and 6. This final pair is what adds to equal +2. So this just factors into y minus 4 times y plus 6, and then we have to make sure to include the -2 that we factored out at the very beginning. So this is why remembering to factor out a GCF is so important. Once I factored that GCF out, it actually made the factoring part of this significantly easier.